Hi class, this is a practice video just like several of the other ones we've done. So what does that mean? You want to use this video and watch it when it's best for you. So if you are pretty solid overall and can do some of the easier proofs on your own, you don't want to try to watch it until you've really kind of given it your all. If you're struggling a little more, maybe you want to do it before you try some of the easier ones on your own, but just whatever works for you. Also remember there is the optional 7.2 reading, which has a lot of strategies and tricks and things like that that you probably want to pay attention to before completing the exercises for the week and doing the harder proofs as well. But that is entirely your prerogative. So today we are just going to work through, or at least tell you how I would work through several of the problems on 229. Start with some of the easier ones and maybe work towards the harder ones. And these are ones I haven't seen in forever, so just going to tell you how I would work my way through them with access to all the same rules you do. So first of all, notice I'm going to read them kind of aloud. Just to remind, because it really helps remind me what they're saying and what I may or may not be allowed to infer with the quantifier rules. For all x, if x has property m, then it's not the case that it has property L. So this might be a way of saying all mammals are non-lizards is a kind of thing that would fit into that. Second premise, in case I didn't mention this, this is number 7, by the way. There exists some x such that nx and Lx. So this is a typical I statement layout. So some quadrupeds are lizards, or some geckos are lizards, that kind of thing. And from that, you're supposed to deduce that some geckos are not mammals. Well, pretty easy to see that that does follow just using my substitution instances. But now we know what we have to do. So again, try not to forget everything from previous chapters. First, I'm going to look at my conclusion and kind of ignore the quantifier, hoping that I could swap the quantifiers in and out as needed. It's a conjunction that doesn't occur anywhere in its entirety in the premises, which means I have to build it. Not very hard to build. It's conjunction. I need to get n by itself. I need to get not mx by itself, so might as well treat these as two. Oh, hey, autofocus, where are you? Sorry. Might as well treat these as two separate conclusions. So I can get this out of premise 2, and I could get this if I do some fancy footwork with premise 1 and a modus tollens, and then conjunction together at the end. But again, pay attention to the quantifiers I'm stripping off. To get rid of quantifiers in premise 1 is really easy. It's true of everything that if it's mammal, it's not a lizard. Whereas premise 2, I'm stripping off an existential quantifier, which has more restrictions. So I'm going to have to be a little more careful with that. So if you're really, as I mentioned last video, if you're really comfortable with the quantifiers, you can start by stripping off the easier one. If you're not so certain with the quantifiers, then you might want to strip off the harder one first. But either way, as long as you do it right. So the more restrictive one, let's just make sure and do the more restrictive one now, is premise 2. Remember, the existential instantiation is what I'm using to strip off. What are the rules there? Basically, you can't change anything, and you can't do anything new, and you can only get a pseudo-constant. So, this is where we usually use our V. There's something that's both of these. There exists some X that's both of these, and then V is what I like to read as my something or other. Something or other has both properties N and property L, such as being a gecko and a lizard. Call it the Geico gecko. That's line 2. Okay, and we just need the V there. That's line 3 simp. Hopefully you're practiced enough you're not doing your double checks on the simp by now, or at least I should say you're doing them automatically. Well, now it's a good thing I started with the more restrictive one, because now I know that for the more general one I need to be working with V's. So this is a good time to strip this off. If it's true of everything, it must be true of the something or other from line 3 and 4. So I will just instantiate this as, if it's true of everything, it's true of V. Line 1, universal instantiation. And now just goes back to something I tried to say a bunch of times early on. I never just simp, I simp com simp. Because look, I still need the LV, so still got to do my com. Still got to do my simp. And it's always good to do that stuff anyway, because even if you get stuck on a proof, as always, there's still some partial credit. Okay, now I need to modus tollens. Hopefully by now you should realize it's not super tricky to do. I'm going to have to double negate first. Line 7 dn, which allows me to do a modus tollens with lines 5 and 8. Allows me to conclude not the case that something or other is M. Geico gecko is not a mammal. There you go. So, because I'm trying to get to here, I can now do the conjunction with lines 4 there's something or other is a gecko, and not that same something or other is not a mammal, as we deduced using lines 4 and 9 conjunction. Well, since there's a something or other that is neither a gecko nor a mammal, it follows that there exists some X such that that X is a gecko and not a mammal. Line 10, existential generalization. And again, I do that one pretty fast because universal instantiation and existential generalization are the easy ones logically. If there's a something or other, of course it follows that there's at least one. And so that's number 7. But notice how kind of both translating and kind of talking through the restrictions and inferences in real language made that proof pretty easy. I'm going to skip number 8 because it's very similar to one we did in the first part of 7.1. But let's go ahead and do number 9. For all X, if X has property T, then X has property V, and X does not have property W. So again, if you want to get kind of think about what these things are saying, well, this is the equivalent of an A statement. All mammals are give birth to live young and are not cold-blooded. Something like that might help to bear in mind as you're working through these. You know what else would help working through these? Writing down the wrong problem, or writing down the right problem. So that is the conclusion we're working towards. My bad. From the premise, for all x, all things that are have property P or property U imply that they're V. So, well, if it's a bird or a mammal, it's warm-blooded. Might help. Let's see. And premise. Well, if it's warm, sorry, for all x, I'm having too much trouble writing. If it's warm-blooded, then, sorry, if it gives birth to live young, it's not cold-blooded. Then that follows from it. Again, I translate a little bit to talk about, it doesn't have to be an exact instance, but I'm translating into the kinds of claims these premises are making, just because that's really going to help me know if I can use one of the more restrictive quantifier rules, such as universal generalization. All right, so I look at my conclusion, which is strangely written up here. Sorry about that. Does it occur in its entirety anywhere in the premises? Nope. Which means I have to build it. This is a conditional. How do you build conditionals? Hypothetical syllogism or conditional proof. So I'm liking conditional proof here. And one of the reasons I like number 9 is to remind you, you still have access to all your other rules. So we just have to be careful about our assumptions. But for conditional proof, I'm going to assume for conditional proof this part of things, because my goal is to just slap a universal quantifier on at the end. So let's assume TV, and then that means I'm trying to get V as property V and V as property not W. It does not have property W. So, well, let's see if I can do it. This doesn't occur in its entirety anywhere in the premises, so I'm going to get this by itself and this by itself. You could start with either one you like, because notice 1 and 2 are universals. They're true of everything. So I can instantiate, if I like, premise 1. Because remember, instantiation is the less restrictive one. So I don't have to worry about that conditional proof rule at the moment. I could just say, well, TV or UV hooks VV. I really shouldn't be saying it like that. I should be saying the properties, but what am I after? By the consequent, which means I need to get this by itself. Pretty easy to do addition, because addition is still in play. And 3 addition, which allows me to do a simple modus ponens. Remember, that was one of the really nice things about conditional proof. Even if it doesn't save you a ton of lines, it tends to reduce a lot of things to modus ponens and simplifications and such. That's half of it. What else do I need to get? Not the case that V has property W. Don't do the mistake I just did. Make very clear what's a V and what's a U. So, once more, I'm looking at premise 2, and that's a universal instantiation. And so there's no problem if it's true of everything. It's certainly true of V. That if V has property big V, then V does not have property W. Line 2, universal instantiation. Again, I don't do a bunch of checks on there because those are the pretty unrestricted rules. And now it's a simple modus ponens from line 7 and 6. All right, now why did I need that? Oh yeah, conjunction. With line 6 and 8. And notice that's what I was trying to prove, which means now I could close off my assumption, and in fact I have to close off my assumption because I have shown one thing. I have shown that the assumption that V has property T implies that V has property V and V does not have property W using lines 3 through 9 conditional proof. Cool. Now I have something that's kind of ish of the form of my conclusion, and so now I need to check to see if I can do a universal generalization. And this is our first universal generalization, so let's really pay attention to the rule here. First of all, the big restriction on universal generalization is that you can only do it with pseudonames, not constants. So notice that's what we have here because we're doing it with a V, which is just the something or other. But does V occur in any conditional proof that has not been closed off? No, it occurs in conditional proof, but it is closed off, so no problem there. Does it occur anywhere in a preceding line obtained by existential instantiation? It does not. We didn't use that rule. And we don't have the double redundancy of using another V, so that's no problem. And then the no changes. So, yep, that is perfectly allowable that I can universally generalize in this instance, line 10. So, no problem there. And again, notice I kind of saw that as I was talking through what kind of things the premises say. That I'm really just moving truths around about generalities, that if it's a mammal, it's not warm-blooded, etc., or it's not cold-blooded, etc. And so we're just shifting around what follows from concepts rather than individual things, and that tends to be a hallmark of when you're allowed to use universal generalization. So that was number 9. It's also a good reminder, in addition to being the first one where we use the universal generalization, it's also a good reminder, conditional proof. Of course you're allowed to use conditional proof. We have the negation rule, so you're also allowed, of course, to use indirect proof. Yeah, use whatever tools are in your toolbox. So let's go ahead and do number 11. Number 11 states, premise, there exists something with property P. Something has P. There exists something with property A. Oops. And notice those don't have to be the same. So there exists a president, there exists a vice president. It certainly does not entail that there exists something that is both president and vice president. That's why some of those restrictions exist, as you were figuring out in your exercises last week. But here's a new premise. Good, some universals. By the way, for reasons Aristotle figured out long before we were doing this kind of logic, conclusions just don't follow from from I and O statements. We need to have some universals in there. For all Y and for all Z, if something is P, something has property P and something different has property A, then Y has bears a certain property to Z. So something like, well, if there's a president and vice president, then L might be the subordinate to relation. From all of that, it theoretically follows, I'm kind of out of room, so I'll write it up here, that there exists an X and there exists a Y such that Y and L YX. Sorry, it's just for some reason it's harder for me to transcribe and talk at the same time when I'm writing these down. So this would be something like, well, from these premises, it follows that there's a president, that somebody is subordinate to them. Again, seems right just from what I've assigned as the translations. And again, you don't have to do that kind of thing, but it really does help see when you're allowed to make the quantifier inferences. So, as always, I look at my conclusion. Does it occur anywhere in the premises? Of course not, which means I have to build it. It's a conjunction, so I'm going to get a py by itself. Going to get lxy by itself. That's clearly a modus ponens job. So let's just get started. Again, if you're good at it, you can start with the harder ones. If not, start with the easier ones. Here's a premise. I need to get some sort of P out of premise 1. So this is an existential instantiation. So remember, that's more restrictive. Means I can only instantiate to a something or other. Call it PV. Yep, there's something or other. There exists a president, so somebody or other is the president. And we're already kind of halfway there, if we could do the existential generalizations correctly, which means we have to modus ponens to get this, which means I also need this and this. So now I'm going to do another existential instantiation of premise 2. Well, and somebody or other is the vice president. We can't call them the same somebody or other, though, so let's call that person U. Somebody or other has the property of being vice president. Cool. And now I just need to be able to do conjunction and modus ponens. So I'm going to do the conjunction now. So now I need to get this in a way that modus ponens, so it looks like that. And again, that should be pretty easy because we're talking universals. It's true of everything. So of course it's going to be true of V. And oh my gosh, I did it again. That's a U. Ugh. So Ulrich Gustafsson sometimes use V and V prime if you have the same problem as I do, making your U's look like V's. So I'm going to have to do two universal instantiations. And sometimes I'll just write down both so I remember. So let's strip off the Y first. Well, if it's true of everything, then it should be true of V. V. I'm replacing all instances of Y with instances of V, and I'm leaving the Z alone. And then I have to drop it again. So now I'm going to, oh, sorry, that's line 3. And then I'm going to do line 7. So now I'm going to drop all instances of Z. If it's true of everything, it must be true of U. So I'm going to carry that down, replace all instances of Z with U. That's a V. That's a U. Yeah, maybe I should just start using the primes. Parentheses. That's line 7. All right. Why did I want to do that? Simple modus ponens will do with lines 8 and 6. Why am I doing that? Because I have this. I need to get L, V, U. Now, I need to conjoin them and put back the quantifiers. So, let's see. I'm going to go P, V, and L, V, U. Using lines 4 and 9, conjunction, junction. And now, if I did this correctly, I should just be able to do two existential generalizations. And again, write that down so I don't forget to do both. Okay, so we take them off going outside in. We put them on going inside out. So I'm going to put my inside one in first. I'm going to put there exists a Y such that Y is the president and some U is subordinate to Y. Can I do that as an existential generalization? Yep, because that's the easy one. We could do it to a pseudonym or a constant. Well, it's true of somebody or other is all we're saying. From the fact that somebody or other is president and somebody or other else is subordinate to them, notice I said else to represent that those are different, it follows that there exists someone who's president and somebody or other else is subordinate to them. And then I just need to do it one more time. And replace all instances of U with instances of X for the win. All right, so for the record, ones like probably about a 9 and 11, that might be about the difficulty of the ones you should expect on the exam. But we've been going for about a half hour. Let's go ahead and just do one more. Because we can, let's do number 12. And hope the stupid thing doesn't freeze like it sometimes does when I start to go long. All right, so number 12 states, there exists an X such that A is X and for all Y, quantifier and a quantifier, it's the first one of those. All B R X Y. So This would be maybe there exists, so this is a relation. Start here, all y bear a relationship to x, so there exists a president, and everybody, if they're in Congress, they answer to the president, kind of thing. So then, premise for all x, if x is the president, then for all y, if they are foreign, then they aren't subordinate to the president. From that, it follows that for all x, if x is in Congress, then they are not foreign. Seems to follow pretty well. So again, translation helps, but it helps you kind of sort these things out, but is not required. So we're obviously going to have to do a universal generalization at the end. So I'm really thinking in terms of B implies S. Well, they're both there, which means if I could flip this over, I could probably hypothetical syllogism or something of the such. However, we're also trying to build a conditional. So I could assume B and just show that not X follows. So either one's fine. Let's go ahead and start with, do you want to start with the assumption or do you want to start with some instantiations? Doesn't matter much. I usually like to do my instantiations outside of the assumption. So there exists something or other. So again, we have to be careful with that. Let's call that AV. And for all y, if by, so notice I'm just replacing the x's, then r vy. That's using line 1, universal instantiation, existential instantiation. That's why I have to keep it at something or others. And now I can do simp com simp. So A, B, then I have the com is just tedious writing. By relationship by, A, B, and then for all y, by. Almost did that right. Again, why am I doing all this now? Because you never know if you're going to need it later, so I like to do these kind of moves outside of the assumptions, including I'll do one last I'll do a universal instantiation. So dare I try it with U again? BU hooks R V U. Line 6, the universal instantiation. All right, now I might go ahead and make an assumption. BU looks like it's going to be helpful here. That's an assumption for a conditional proof. And again, optional step, I'm trying to therefore get to not yes, U. So, well, notice I still haven't done anything with premise 2, so let's go ahead and instantiate that. I need an A such that it matches there, and it's universal, so I could do that. We'll say V as property A, then for all y, sy hooks, not the case that R, V, Y. Line 3, universal instantiation. Notice I can't instantiate part of a line, so I'm going to have to do my modus ponens first. So that is lines 9 and 4. Gives me, for all y, if S has property y, then V bears relationship to y. And so again, V should really read as a something or other there. So now what am I trying to get to? Oh yeah, not this. So I think I left a negation somewhere. Yes, that's a negation. That would be almost turn that invalid. Watch for that. I can get not RVU, so let's go ahead and instantiate that for SU hooks. It's not the case that RVU, using line 10, universal instantiation, which again is a pretty loose one. So now I can get RVU and then just do a modus tollens. That's using lines 7 and 8 modus ponens, which means I have to once more double negate this first. On 12 double negation, which allows me to do a modus tollens, not U does not have property S, using lines 11 and 13 modus tollens. And that was my assumption for the conditional, so I can close off my assumption because I've proven beyond a shadow of a doubt that if something or other has property B, it does not have property S, using lines 8 through 14 conditional proof. Okay, now the question is, can I therefore universalize it to go for all X, Bx then not, case that it has X, that would be line 15, universal generalization if it's a go, but let's double check. First and most important, I did this with a pseudonym, right? I did it with a something or other. Second of all, does it occur in an unclosed conditional proof? No, I closed my conditional proof, so you don't have to worry about that. What about existential instantiations? I do have some of those. So does this occur by an existential instantiation? No, right? It's asking if this, my beta, occurs as an existential instantiation. It does not. It's a derivation from conditional proof. And then I'm not doing anything sneaky by trying to double up on variables, so requirement 3 is met, and then 4, I didn't change anything, which means Veni Vidi Vici. So that's some practice, but again, your job, practice, 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 practice. And that's pretty much it for proofs after this. If you could do the 4 I did today on your own, you are in good shape for the final exam, at least for that section of it. After today, then we're going to do 2 quick lectures on some small and interesting other stuff in logic, and then we will call it a semester.